Welcome back, everyone. Today's deep dive is going to be fascinating. We're tackling Gottlob Frege.
Fascinating guy.
He's one of those thinkers that, most people probably haven't heard of.
Right.
But his work has had a huge impact on, how we think and reason today.
Absolutely. What's so interesting about Frege is that he wasn't just content to accept the traditional ways of thinking about logic. He wanted to really dig deeper and uncover the fundamental principles that underpill our reasoning.
And he, totally revolutionized the field with his system known as predicate calculus. It's like he took that old Aristotelian logic and gave it a 2.0 upgrade.
Yeah, like imagine trying to build a skyscraper with just a hammer and nails.
Okay.
That's what traditional logic was like. Then Frege come along, gives us cranes and blueprints, a whole new set of tools to construct complex logical structures.
I love that. That's a really great analogy. So he's this brilliant logician, develops this powerful new system, but he also had this really ambitious goal to demonstrate that all of mathematics could be reduced to logic.
Yeah, this is what's known as logicism.
Logicism.
Yeah, Frege believed that the truths of arithmetic, they weren't just some kind of separate, self-evident truths. He thought they could be derived from pure logic. Basically, the whole edifice of mathematics could be built on this foundation of just logical principles.
Whoa. That's a bold claim. It's like saying all these complicated equations and theorems in math are really just logic dressed up in a fancy outfit.
That was his big idea. And to prove it, he wrote this massive two-volume work called Grundgesetze der Arithmetik, just filled with intricate definitions and proofs, a real testament to his meticulous nature and just his quest for this, total logical rigor.
Wow. But there's a twist, right? There's something about a letter from Bertrand Russell.
Oh, yes, Russell's famous letter. It's a story that really highlights the challenges that even the greatest minds can face. Right as Frege was about to publish the second volume of his masterpiece, he gets this letter from Russell pointing out a fatal flaw in his system.
Oh, no.
It was a contradiction, now known as Russell's paradox. It basically showed that one of Frege's, fundamental assumptions led to this absurdity.
It's like you spend years building this magnificent castle, and right as you're about to unveil it, you find out the foundation has this crack that threatens to bring the whole thing down.
Yeah.
Devastating.
Absolutely a major setback, but even with this flaw, Frege's work in Grundgesetze is still incredibly influential. It really laid the groundwork for modern logic and spurred so much further research in the foundations of mathematics.
So we have this brilliant but somewhat tragic figure, revolutionizes logic, tries to rebuild math from the ground up. But who was Gottlob Frege, the person? Where did all these ideas come from?
Well, he was born in 1848 in Germany, spent most of his career as a professor at the University of Jena. Trained in mathematics, but his interests, they really extended far beyond that. He was a deep thinker, constantly exploring the nature of thought, language, and knowledge.
So he wasn't just like, some ivory tower mathematician crunching numbers all day.
Not at all. He was fascinated by the big questions, the fundamental philosophical puzzles that have always captivated thinkers, and he believed logic was the key to unlocking those puzzles.
So how did his journey begin? Where did he start developing these revolutionary ideas about logic?
His early work provides some clues. In his habilitation shift, which is like a super thesis, you had to write to become a professor.
Oh, wow.
He explored the concept of quantity in mathematics.
Okay, quantity, measuring things.
Exactly. But it wasn't just about simple measurement. He was grappling with how the concept of quantity, had to evolve with the introduction of complex numbers.
Huh.
Think about it. We used to understand, length as something very concrete, like the space between 2 points. But with complex numbers, all that matters are the starting and ending points, not the space in between.
So the way we think about something as basic as length had to be completely reimagined.
Right. Frege realized that this shift to complex numbers implied a more abstract understanding of quantity. He started questioning whether our intuitions about space and measurement were always reliable guides to mathematical truth.
That's interesting. It makes me think about how he was also aware of Weierstrass's discovery of this continuous but non-differentiable function. Essentially, it can't be graphed, right?
Right.
That must have just cemented his doubts about relying solely on intuition in mathematics.
Precisely. He saw that intuition could be misleading, especially when you're dealing with abstract concepts. And this skepticism toward intuition became a key driving force behind his work in logic and the foundations of mathematics.
So it's like he was saying, let's not just assume things based on what feels right or what we can picture in our minds. Let's build a system of thought that's grounded in solid logical principles.
Exactly, and that's precisely what he set out to do. His work on quantity was just the beginning. It led him to explore the relationship between geometry and number theory, and really question the very foundations of mathematical reasoning.
So how did this questioning of intuition and this fascination with quantity lead him to develop his groundbreaking logical system?
Well, Frege realized that to build a truly rigorous foundation for mathematics, he needed a more powerful and expressive logic than the traditional Aristotelian system. He needed a logic that could capture the nuances of mathematical reasoning, a logic that could handle these really complex concepts and relationships.
So what did this new logic look like? How is it different from the old way of doing things?
One of the key differences is that Frege's logic is a term logic. Think of it like mathematical expressions, like 2, 2 plus 2, 2 plus 2 equals 4. These are all terms that denote numbers, right?
Yeah, they all represent specific numerical values.
Exactly. But here's the thing. For Frege, even sentences are terms that denote something.
Oh,
And what they denote are truth values, the true or the false.
okay.
So like 2 plus 2 equals 4, that denotes the truth value, the true, and 2 plus 2 equals 5 denotes the false.
So sentences become like names for truth values. That's pretty different from traditional logic.
It is, and it's a fundamental difference between Frege's logic and the kind of logic we, typically learn about. This distinction is really crucial for understanding how Frege approached the analysis of language and meaning.
Okay, I'm starting to see how this all fits together. But how did he handle, like, predicates? Like in a sentence, John is happy. In traditional logic, you break that down to the subject, John, and the predicate is happy. How did Frege deal with that?
Well, Frege's system, it's all about functions. Remember how we were talking about those mathematical expressions, being terms that denote numbers?
Right.
Well, for Frege, predicates also signify functions.
Okay.
So is happy signifies a function that takes an object as an argument and outputs a truth value.
Right.
If the object is happy, the function outputs the true, otherwise the false.
So instead of separating the subject and predicate, he sees the whole thing as this function, like he's almost analyzing language through a mathematical lens.
Yeah, that's a great way to put it. He's bringing the rigor and precision of mathematics to the study of language and logic. And this function-based approach, it allowed him to analyze more complex sentences as well. For example, John loves Mary. Loves is a function that takes two objects, John and Mary, as input, and output you a truth value based on whether that relation holds true.
So loves isn't just like a word connecting two names. It's a function that operates on those names to produce a truth value. Okay, it's starting to click now.
Great.
But language can get even more complex. Like, what about words like every and some? How did Frege's system handle those?
This is where things get really interesting. He developed a symbolic way to represent these concepts, which we now call quantifiers. So, for example, take the sentence, everything is mortal. In modern notation, we write that as, for all x, x is mortal. Frege had his own symbolic way to represent this, but his system could capture the same logical structure.
So he went beyond simple subject-predicate logic and found a way to express these more complex ideas about quantities and relationships. That's incredible. I'm guessing it wasn't all smooth sailing, though, right? His system was so complex and ambitious.
Yeah, you're absolutely right. While his system was incredibly powerful, it also had its challenges.
His system was so complex and ambitious. I bet there were challenges.
We're right. While his system was incredibly powerful, it also had its share of challenges.
What kind of challenges?
One of the biggest was dealing with the concept of extensions. Remember how we discussed that Frege's logic is all about functions and objects?
Yeah.
Well, he wanted to expand the domain of objects to include something he called courses of values. Essentially, a course of values is like a record of the output of a function for every possible input. Imagine this massive spreadsheet, right?
Okay.
And it shows what a function does to every single thing you could possibly feed it.
Oh, wow. Okay, like this giant cosmic spreadsheet mapping out all the inputs and outputs.
Exactly. And the course of values of a concept, which is a special kind of function he called an extension.
Okay.
So the extension of a concept is like a list of everything that falls under that concept. For instance, the extension of the concept cat would be a list of every single cat in existence.
So the extension is like the complete set of things that a concept refers to. So Frege thought these extensions could be treated as objects themselves.
Precisely. He wanted to include them in his logical system as objects, but this led to some pretty serious problems. To systematize extensions, he relied on something called basic law V,
Basic law of V.
which basically said that two functions have the same course of values if and only if they give the same output for every input. Pretty straightforward, right?
Yeah, sounds logical enough. Like if two functions do the exact same thing, then their courses of values should be the same.
It does seem intuitive, but Russell, he discovered this fatal flaw in basic law V. He showed that it actually leads to a contradiction.
Oh.
This contradiction, now known as Russell's paradox, it basically implies that there are extensions that both are and are not members of themselves. and that's a big no-no in logic.
So his attempt to incorporate extensions into his system kind of backfired in a spectacular way. Like he added this new wing to his logical cancel, but the addition turned out to be unstable and threatened to bring down the whole structure.
Yeah, that's a great way to put it. The contradiction really exposed a weakness in his system and ultimately undermined his project of reducing mathematics to logic. It was a major setback for Frege, but even with the contradiction, his work on extensions is still incredibly fascinating and insightful. It really spurred further research in the foundations of mathematics and led to important developments in set theory.
Yeah, it's amazing how even in his failures, Frege's work had such a profound impact on the field. He was really pushing the boundaries of logic and mathematics, and even when he stumbled, he opened up all these new avenues for exploration.
Absolutely. Now, despite the setback with extensions, Frege's exploration of how logic intersects with language was super influential. He made this brilliant observation about statements of number, sentences like, there are 8 planets or there are 3 cats in the yard. He realized that these statements weren't just about numbers, they were about concepts.
Wait a minute, how are statements of number about concepts? They seem pretty straightforward to me. You're just counting things.
That's what's so clever about Frege's insight. He realized that you need a concept to even count something. For example, you could describe the same group of objects in multiple ways. You could say, there's 1 army, there are 5 divisions, or even there are 20 regiments. The question, how many? It only makes sense once you know what concept you're using to group the objects.
Ah, I see what you mean. The concept determines what you're counting. So how does this relate to statements of number?
Well, Frege's breakthrough was to recognize that a statement like, there are 8 planets, is actually saying something about the concept planet. It's saying that the concept planet falls under this higher order concept, something like being a concept under which 8 objects fall.
Okay, so we're talking about concepts of concepts now. Things are getting pretty meta.
Yeah, it is. But the brilliance of it is that Frege was able to define this higher order concept without actually using the concept 8. He did it using purely logical terms, building up from the ground level.
So he's showing how the concept of number can be defined using logic, which ties back to his Logicism project. It's all connected. And this led him to his next big challenge, right? Defining individual numbers and the concept of natural number.
Exactly. He needed a way to define numbers like 0, 1, 2, 3, and so on, using only logical concepts. And to do this, he started with this seemingly simple idea of one number preceding another.
Okay, precedes. So like 1 precedes 2, 2 precedes 3, and so on.
Exactly. But Frege, always the meticulous logician, wanted to define precedes in a precise and rigorous way, using only concepts and objects.
Okay.
He said that X precedes Y if and only if there's some concept and some object under that concept, such that Y is the number of objects falling under the concept, and X is the number of objects falling under that concept, but excluding that one specific object.
Whoa, that's a mouthful. Can you give me a concrete example to help me wrap my head around that?
Sure. Let's say we have the sentence, 1 precedes 2. Frege's definition will be satisfied here because we can choose the concept. Author of Principia Mathematica.
Okay, Principia Mathematica. That was written by Alfred North Whitehead and Bertrand Russell, right?
Get it. So 2 is the number of objects falling under that concept, Whitehead and Russell. And if we exclude Whitehead, 1 is the number of objects falling under the concept, just Russell.
Oh, that makes sense. So he's defined precedes in terms of concepts and objects, showing how one number comes before another in this logical sequence. And then he used this idea of precedes to define the concept of natural number, right?
Exactly. He realized that if you start with 0 and just keep applying the concept precedes, you generate all the natural numbers. So he defined a natural number as either 0 or something that 0 precedes in a chain of precedes relations.
So it's like building a staircase one step at a time. Using this logical concept of precedes, he's constructing the entire number system from the ground up, using logic as his building blocks.
That's mind-blowing. But I'm also sensing a pattern here. Frege seems to run into trouble whenever he tries to connect his logical system to the real world, whether it's with extensions or defining numbers. It's like he can build this amazing airtight logical structure, but as soon as he tries to apply it to concrete things, cracks start to appear. You've hit on a crucial point. There's this tension in Frege's work between the purity and rigor of his logical system and the messiness of the real world. His Logicism project, while ambitious and groundbreaking, it ultimately faced these challenges because it tried to reduce the richness and complexity of mathematics to this purely logical foundation. But these challenges, they don't diminish the brilliance of his work at all.
It's like he was trying to build this perfect crystalline structure to represent the world, but the world itself is inherently messy and imperfect.
That's a great analogy. But this tension between logic and the world, it actually led him to make another groundbreaking contribution. His theory of sense and denotation.
Okay, sense and denotation. This is where he tackles those really cool puzzles about language and meaning, right?
Absolutely.
Okay, sense and denotation. This is where he tackles those really cool puzzles about language and meaning, right?
Absolutely. Frege realized that the meaning of a word or a sentence, it's not like as straightforward as it might seem. There's more to it than just what the word refers to in the world.
Okay, I'm intrigued. What kind of puzzles led him to this idea?
Well, one puzzle has to do with identity statements. Sentences like, the morning star is the evening star, or Mark Twain is Samuel Clemens. On the surface, these statements, they just seem to be saying that two different names refer to the same thing.
Right, like they're just saying that these two labels are attached to the same object.
Exactly. But Frege, he noticed something peculiar about these identity statements. Consider the sentence, Mark Twain is Mark Twain. It's obviously true,
Yeah,
but it doesn't tell us anything new.
right.
It's like saying A equals A, kind of pointless.
Yeah, it's true, but not very informative. We already knew that Mark Twain is, well, Mark Twain.
Now compare that to Mark Twain is Samuel Clemens. This identity statement, it's also true,
Yeah,
but it gives us new information. Like, we might not have known that Mark Twain was Samuel Clemens' pen name.
so both sentences are true identity statements, but one feels trivial and the other one feels informative. Why is that?
That's the puzzle, right? If identity statements are simply about whether two things are the same, then how can A equals A and A equals B? How can they have different cognitive values when they're both true?
Yeah, that's a really good point. If Mark Twain is Samuel Clemens, then those two sentences should be equally informative or equally uninformative, I guess. But they're not. It seems like there's something more to meaning than just what the words refer to.
Exactly. And this is where Frege's distinction between sense and denotation comes in. He argued that in addition to a denotation, which is the object an expression refers to in the world, expressions also have a sense, which is the way in which that denotation is presented or conceived.
Okay, so the denotation is the actual thing in the world, and the sense is like the way we think about that thing, the way it's presented to our minds.
You got it. Think of it this way. The expressions 4 and 2 plus 2, they both denote the same number,
Right.
but they present it in different ways. 4 is just the straightforward name for that number, while 2 plus 2, it presents it as the result of an addition. They have different senses, even though they have the same denotation.
So the sense is like the mode of presentation, the way we grasp the meaning. That makes sense. And this applies to names as well, right? Like Mark Twain and Samuel Clemens both denote the same person, but they present him in different ways.
Precisely. Mark Twain, it might bring to mind the author of Huckleberry Finn, while Samuel Clemens might make us think of the person born in Missouri in 1835. They have different senses, even though they refer to the same individual.
Okay, yeah, I'm starting to see how this solves the puzzle about identity statements. The sentence, Mark Twain is Samuel Clemens, is informative because it's telling us that these two different ways of thinking about the same person, these two different senses, they actually pick out the same individual in the world.
Exactly. The different senses, they create this cognitive difference, even though the denotation is the same. And Frege actually used this distinction to solve another puzzle as well, one that deals with what are called propositional attitudes.
Okay. Remind me what those are again?
Propositional attitudes, they're basically ways we relate to thoughts or propositions.
Okay.
Things like believing, knowing, hoping, fearing. We express them in sentences like, John believes that, or Mary hopes that.
Right, they're about our mental states, like our attitudes towards certain propositions.
Exactly. And the puzzle here is that there's a principle about substituting names in sentences. And it seems to break down when we're talking about belief.
Okay.
Let's call it the principle of identity substitution.
Okay.
This principle says that if you have a true sentence and you replace a name in it with another name that refers to the same thing, the sentence should still be true.
Okay, yeah, that seems reasonable. Like if Mark Twain was a writer is true, then Samuel Clemens was a writer should also be true, since those names denote the same person.
Right. But this principle, it seems to fail when we apply it to sentences about beliefs. For example, consider the sentence, John believes that Mark Twain wrote Huckleberry Finn. Let's assume John knows Mark Twain as the author of Huckleberry Finn, but has no idea that his real name was Samuel Clemens.
So John only knows Mark Twain through his pen name.
Exactly. In this case, even though Mark Twain is Samuel Clemens is true, the sentence, John believes that Samuel Clemens wrote Huckleberry Finn, might be false. John might not connect the name Samuel Clemens with the author of that particular book.
So even though the names refer to the same person, you can't just swap them out in a belief sentence and expect the truth value to stay the same? That's really strange.
It is, and this is where Frege's sense denotation distinction it comes to the rescue once again. He argued that when names appear in sentences about beliefs, they shift their denotation from the usual object to their ordinary sense.
Wait, so the name Mark Twain doesn't refer to the actual person when it's inside a belief sentence?
That was Frege's radical idea. He suggested that in these contexts, names denote the sense that they usually express, not the object itself.
Wow.
So in the sentence, John believes that Mark Twain wrote Huckleberry Finn, the name Mark Twain. It actually denotes the sense of Mark Twain, which is something like the author of Huckleberry Finn.
Okay, so inside the belief context, the name refers to, like, a way of thinking about the person, not the person themselves.
Exactly.
That is so mind-bending.
It is, and this explains why you can't just simply substitute Samuel Clemens for Mark Twain in this case. Even though they might denote the same individual, in the real world, in the context of John's belief, they denote different senses.
Ah, that clears things up. The sense denotation distinction, it explains why that substitution seems to fail, because the names are actually shifting their denotation within the belief context.
Exactly. Frege's solution to these puzzles, it really revolutionized the philosophy of language. It introduced this idea that meaning is context-sensitive, that the way an expression functions can change depending on where it appears.
Like, the meaning of a word isn't fixed. It's like dynamic, and it can shift depending on the surrounding context.
Precisely. And this idea has had a huge impact on how we understand language and meaning today. It's a testament to Frege's genius that he was able to develop such a powerful and insightful theory.
So we've explored Frege's groundbreaking work in logic, his ambitious but ultimately flawed Logicism project, and his really just mind-blowing theory of sense and denotation. It's clear that his contributions to philosophy, they're so profound, and they continue to influence us today.
Absolutely. And, his analysis of language, it wasn't just some abstract intellectual exercise. He was really driven by this deep desire to understand the foundations of knowledge and reasoning, to build this system of thought that was both rigorous and comprehensive.
Yeah, like he was on this quest to uncover the hidden logic of the universe, to find the fundamental principles that govern how we think and understand the world. And even though his journey had its twists and turns, he really left us with a legacy of ideas that continue to inspire and challenge us today.
Absolutely. It's been a pleasure delving into this intricate world of Gottlob Frege with you. His work really reminds us of the power of rigorous thinking, the importance of questioning assumptions, and just the enduring allure of philosophical puzzles.
I couldn't agree more. A huge thank you to you, our expert guide, for navigating us through this really complex and fascinating terrain. And to all of our listeners out there, thank you so much for joining us on this deep dive. We hope you've gained a newfound appreciation for the profound impact that Gottlob Frege has had on our understanding of logic, language, and the very foundations of thought.